Hey, welcome back. This is Brother Barnes, and we're doing a density lab report in Excel. And this is draft 2. This is going to be a major overhaul, so let's get busy. I wanted to say density of wood lab report, and I wanted to replace other team members with something a little bit more descriptive. Let's go right here and let's paste. Okay, that works. Let's tab over. The date due is to be announced. Let's do that. I wanted to elaborate a little bit on the introduction. So we're going to insert a little bit of information right here. Talking about density, so let's see how this fits, and we'll get all the text lined up so that maybe we can read this. Since we're doing a density study, I thought a little bit more practical background information would be good. A large object may be light, such as a big piece of styrofoam. Lead may be small, but due to its compact nature is heavy. A feather is not very dense, but a coin is dense. And then I went on to elaborate from what we did last time. What is density? Let's talk about the hypothesis. If water is 1 gram per cc, then we expect the density of wood to be less than 1 gram per cc since it floats on water. Okay, I've got an additional help right here that will describe a little bit more of what we did. All right, let's get that to 14 again. Mate, come on, give me 14. There we go. Measurements in grams and dimensions measured in centimeters were used to determine the mass and volume and thus the density of the wood blocks through calculation using Excel formulas. Very good. Okay, let's go to the materials, methods, procedure. Written in past tense, I realized that I did not do well at all on that last time, so let's try to do past tense. The mass of the wooden blocks was, how about that, was, not was be, was measured in grams on a top loading scale, and the volume was, past tense, approximated by measurement in centimeters of the 3 dimensions of volume: height, width, and depth, comma, with a metric ruler. How about that? There are 2 these right here. Did you see that? The. Okay, we got that taken care of. Okay, very good. I think this page is nice. Now, bear with me for just a second. Is there a way to do a check on that? A spell check, edit? We might go back and figure out if we can do that so that we can catch some errors. Since you and I have been together last, you've seen this data and data analysis page already, but I did an outlier calculation. I did that. And then I also did a density unit calculation. I went to a website and I was looking up density, and it was giving these units, and I didn't know if it was grams per cubic centimeter or not. I found out in the end that it was. But let's go into discussion and conclusion, because that is actually what I'm trying to do, get this second draft knocked out. Now, I'm going to say that I want to add a page for resources cited. So let's go do that. And let's insert a text box here. Let's insert a text box. That's good. Let's do that. And then let's right click on sheet and let's rename this MLA. I did not mean to do that. A resources. Let's make that caps. I don't want to do it. There we go. That's kind of how I want it to look. Perfect. Let's go back to discussion and conclusion, and let's pull this out of here. I just added a new. Let's cut that, and I want to go to resources cited. That's perfect. To do the outlier calculation, I cited a textbook I used last summer, Elementary Statistics. And let's make sure that that is that 14? It is not, but let's make it so, because I've got another resource, or yes, another source cited. Actually, when we say resources, that's really not what I meant to say, is it? I wanted to say other sources, not resources. It is a resource, but that's not the right way to say that. There we go. Maybe that's where I got that from. Sources cited. I like that better. Okay, thank you. I need to fix that in my cut and paste template, don't I? All right, let's go back to discussion and conclusion. Instead of saying our experimental average density, I'm going to say the experimental average density. Okay. For the blocks of wood measured was 0.5 gram per cc. Water has a mass of 1 gram per cc. The density of much less than water explains. Okay, that is very awkward right there. I'm just going to say this explains the ability of wood to float on the water, on the water. Okay, that sounds fine. And let's say that our hypothesis was upheld. Let's say this, and I'm going to copy and paste this so that it doesn't take excessively long. Let's copy that. Let's state this out loud. I did not mean to do that. Paste. There we go. There we go. And let's go with a 14 on that. The hypothesis that wood has a density less than water was upheld by our data. Okay, I think that's fine. We are not going to do experimental error here. We used other data analysis tools. I actually wanted to get rid of this whole section. I rewrote this, and I want you to take a look with me, and I'm probably going to need every bit of room to squeeze this in. I did not mean to do that much, though. I didn't want to scoot it over and make the page too big, so let's scoot it back. Okay, there, almost. Hold on. All right, we're getting there. We are getting there. There we go. Okay, now everything is in the picture. So I want this large paragraph to go in that spot, and I'm going to put it really tiny as about a 9 font, just to get it in on the page. Let's hit copy, and we're going to paste that over here, and we'll see how we can fit that. There we go. Very nice. Now, we may not be able to roll with a 14 on this page, so let's see what we could do, and I want you just to kind of read through this with me real fast. Okay, hold on a minute. Why can't I get to my, let's go home. There we go. Now let's try this. Let's highlight it again. Let's go home, and let's click can we get a 12 in there? But, oh, wow. Okay. Well, that's nice. 14 is what I wanted. So, lovely. All right, here we go. Let's read through this. I want you to listen to it, see what you think. This is probably going to be the end after I put in another reference at the very end. This is going to be the last of this draft. So if we need to do something else, we'll have to do it next time. Discussion and conclusion. The experimental average density for the blocks of wood measured was 0.5 grams per cc. Water has a mass of 1 gram per cc. This explains the ability of wood to float in the water. The hypothesis that wood has a density less than water was upheld by our data. Lovely. Beautiful. The density of wood data was calculated using formulas in Excel. A whisker plot revealed the grouping of the data and gave numbers which could be used in an outlier boundary calculation. Additionally, the density data was analyzed using Excel analysis toolpack. The analysis of the data toolpack agreed with the whisker plot data on comparable statistics. It was determined. That means if mean was shown in one, it would be the same value in the other. That's what I'm trying to say there. Let's spell that out. Mean in one. Okay. I can spell it out there. Rocked a little bit off the bottom right there. Is that all going to fit still? Kind of. Let's back this up. Okay, there we go. It was determined that the 0.72 gram per cc density and the 0.37 gram per cc density were outliers. And if you look, I actually went back and did the outlier calculation. The upper level was 0.57, lower 0.41. Both of these values were outside of that those boundaries. Let's go back. The 0.72 gram per cc value is not considered error since it is composed most likely of oak or some other hardwood. The blog wood density chart on the blog workshopped the article, I should say, the article. Wood density chart on the blog workshop lists the density of oak to range from 0.6 to 0.9 gram per cc or 1,000 kilogram per meter cube, which I checked by dimensional analysis to be equivalent to grams per cc. By the way, that is here. I checked that and I did a video on that, dimensional analysis. If you need to know how to do dimensional analysis, there it is. Let's go back to discussion. Or 1,000 kilogram per meter cube, which I checked by dimensional analysis to be equivalent to grams per cc, with red oak listed as 0.74 grams per cc, which is about the value determined experimentally in this trial, which was 0.72. 0.72 grams per cc. There we go. White pine is listed with a density range of 0.35 to 0.5 gram per cc. The experimental density of 0.37 gram per cc does fit into this range, but I think it is in error since the measurements represent almost a perfect square on the block measured. All right, and to review that piece of information, let's go back to the top. Here's the 0.37. Notice that the height 7.5, width 7.7 and 8, depth, that's almost a perfect square. Not quite, but I don't think we had any blocks that were shaped like a perfect square, so that's why I don't think that is a valid data point. There were no pieces of wood measured that were a near perfect square. The teacher, me, should have logged the numbers of each piece of wood for each lab participant, but did not. I could probably use some clarity. The 0.37 gram per cc measurement is likely an error in measurement. The average density in the experiment of 0.5 grams per cc is a little high if only pine was considered. It is the data from the piece of oak that elevated the average a bit above the median, which was 48 gram per cc. And then I did at the very end, which we might connect this a little bit better, the hypothesis that wood has a density less than water, 1 gram per cc. 1 gram per cc was upheld by our data. Very good. Okay, so let's go to Mla Sources Cited, and I do have a citation for the blog that I picked up where I got the density information. We're going to paste that here, and let's put that at 14 as well. Let's go to 14. And remember that the Mla citation has a little bit of an indentation here. So we're going to click, right click, and let's go to paragraph, and we're going to do a special hanging indent of a 1/2 inch to, okay, that should work. Why would that not work? Hold on a minute. Let me try that again. There's no reason why that should not work. Paragraph, hanging by 0.5. Okay, well, that should work. I think what I'll do to fake it is just hit tab. That's too much of a tab. Well, it's complicated. I think the reason is that, okay, let's try this. Let's shift this. This will make it work. It's because it's in the middle of a link. Okay, now let's see if we can make this fly. I think we'll get it this time. Let's go to paragraph again. Okay, that still didn't work. So now let's try a tab here. That's too much of a tab. How about, can we do like 2, 3, 4, 5? That's kind of it. I think for now we're gonna have to leave it at that. And if your teacher burns you for that lack of indent there, you and I will just have to get burned. Yeah, I make 93s and 92s a lot. I don't always make A+ 100 like Grandma Barnes once. Anyhow, that is a very nice. I like it. This needs to be shrunk down a little bit, I think. Can we get that all in one page? Almost. Hold on a minute. Let's get everything where we can see it. I'd really love to do that before we get done. No, I don't want to cut anything off though. Hold on a second. Let's pick it all and let's see if we can shrink it to like a 12. Can we get everything on one page where we can see it? Good. That is a good second draft. I'm happy with that. We've got our data. We've got our outlier calculation. I've done a video on that one, and then to keep going, I've got a density unit calculation, which looks a little bit rugged, but it works. And then discussion and conclusion. Okay, I'm good with that. It's all on one page. And then our sources cited. This is going to be MLA style, and I'm not really happy there, but as you can see, I tried hard to make that work. So let's make sure we click save. We should always do that. That's one thing that I have not emphasized, but that can make a lot of misery if we don't save. Second draft of the density lab report